Welcome to the SimForm Feasibility Project tutorial. In the plastic injection industry, conducting a part analysis is a fundamental step to make informed decisions and ensures optimized outcomes during the quoting process before designing the mold. The feasibility project uses the plastic part's geometry, assumes a well-designed mold, and considers your mold and plastic part materials to determine an efficient cooling time and temperature distribution for your plastic part. The feasibility analysis lets you estimate an efficient cooling time for your plastic part to set clear mold cycle time targets before designing the mold. It lets you identify hotspots within the plastic part to anticipate challenges and risks early in the mold design process and provides valuable feedback to the part designer. And it lets you test various materials for both the plastic and mold components to select the most optimal materials. Sign up for a free trial today and experience the convenience and efficiency of SimForm. In this step-by-step demo, I will show you how to set up and solve the feasibility analysis and interpret its results. First, I will create a feasibility project. On the Projects page, I will expand the project types list and select Feasibility Project. Then I will click Feasibility Project. When I create a new feasibility project, I redeem 3 credits from my credit balance. With each project, I can simulate up to 5 different scenarios without using additional credits. In the Add Feasibility Project window, I will type a meaningful name that identifies my part design, for example, pipe fitting, and then I'll click Add. In the Add a New Job window, I will name the job, and then I will click Select File, select the CAD file with the plastic part design, and click Add. Next, I will assign the material properties for the plastic part and the mold. In the Mold Material panel, I will expand the Select Material list and select the mold material, for example, Steel 4140. I can also create a new customized material for the mold using the procedure described in the Creating Custom Materials in SimForm video. SimForm assumes a well-designed mold in the selected material, and it considers the effect of the mold material on the part quality. So next, I will select the plastic part and click Add in the Plastic Part panel to define it. I will expand the Select Material list and select the plastic part material, for example, acrylic. Selecting the plastic part material sets the injection temperature of the plastic and the target mold temperature, which is based on recommendations of the plastic provider. I can keep the default temperature based on the selected plastic material, or I can modify it if necessary. Now, if my model includes runners, I will use this panel to define them. I can now click Submit Job to solve the model. Solving a feasibility analysis usually takes less than 10 minutes. For this model, it takes 5 minutes. The feasibility project uses cloud-based GPUs and automated meshing, making the solving time fast and efficient. When the solve is finished, I will click Results to open the results page. In the Display Mode panel, SimForm displays the freeze time. Freeze time, or safe ejection time, is the duration for the plastic part to develop a thick enough solidified layer, ensuring the safe ejection of the part while preserving its integrity. The overall freeze time, which represents the shortest duration that the part should spend in the mold before safe ejection, is displayed on the top of the Model View window and in the Job panel located on the left. Now I'll rotate the model to explore the local freeze time results in the plastic part. I can use the local freeze time results to identify areas that need a longer time to cool down. This helps me optimize my plastic parts, such as reducing wall thickness and improving cooling system design, such as adding highly conductive inserts or adding baffles. I can use the global freeze time to accurately estimate the part cost for a quote and provide a realistic cycle time target for the mold maker. And once the mold is designed, I can compare the actual mold cooling performances to an ideal mold. I can also select plastic surface or plastic volume to display the temperature distribution either on the surface or within the volume of the plastic part. The surface temperature distribution shows that the high temperature zones are in the inner surface of the plastic part. I can use the temperature distribution results to identify potential problem areas such as hotspots and get valuable feedback to part and mold designers. I can also click anywhere in the plastic part to display its local result. I will now select Filter Plastic and move the slider to select the minimum temperature limit that I want to display, for example, 80 degrees Celsius. SimForm displays areas of the plastic part where the temperature is higher than the specified temperature. This lets me identify the different areas of the plastic part, those that are within the safe ejection temperature range, those that are still in a liquid state, and those that exceed the melting point of the plastic material. The SimForm Feasibility Project's fast setup and runtime lets you analyze parts at varying levels of maturity, helping you make informed decisions early on, reduce risk, and streamline your workflow. This approach lets you accurately estimate short and realistic cooling times and set clear mold cycle time targets. You can also identify process improvements to proactively recommend and implement design changes and minimize uncertainties when quoting manufacturing costs. Thank you for watching this tutorial.